Hi everyone, today I'm going to take you through the uses, stroke applications of manual welding. Number one, it is used in the manufacturing process of pipelines. Then the example I can give here is like if you look at the oil sector, basically the oil and gas sector, you find that different pipes of different thicknesses or different pipe fittings and components are being joined together. And in most cases, they also employ or they always employ manual welding process. Number two, in shipbuilding industry, we all know that ship have got thicker bodies or are made out of thicker materials. So implying that for them to be properly joined, they have either to employ manual welding. And then number three, in sheet metal industry. In sheet metal industry, basically we look at the components which are being produced or the machinery employed to produce those components. So you find that if you look at the machinery themselves, they have got thicker materials, implying that they're supposed for them to be properly fabricated and joined together, you're supposed to employ manual welding. Then number four, in production of pressure vessels or steel structures. So for pressure vessels, basically we look at both the oil and gas tanks, underground and overhead. And when it comes to the steel structures, basically we look at the columns and beams. So since these columns and beams or even trusses, they are a bit thicker, they're made of thicker materials. So for them to be properly joined or welded, in most cases we employ manual welding. And then lastly, in automotive industry, here we look at different car bodies or different car components or vehicle components being fabricated or being welded using manual welding. Let's quickly look at the advantages of manual welding. Manual welding creates no oxidation because the weld area is protected by the shielding gas. So look at given, for example, if you look at the carbon dioxide being joined with argon. So as someone is performing the weld, the shielding gas will always come and cover the welding pool, both the weld and the weld, half of some good area of the welding pool, implying that it is protecting the weld area from the atmospheric contamination. Then number three, it is a fast welding process, which means that there is a low heat effect on the surrounding material. So if you look at the practitioners of manual welding, they always, since they have the good skills and experience, so when someone is doing this kind of welding, find that the process is very quick and fast, implying that the other surrounding regions or around surrounding materials will not be affected. Then the last one is our number three. MAG can be performed in all positions, making it one of the most widely used welding process. It is true, because if you look at the welding torch for MAG welding, it is given a specific welding angle, implying that one can weld in 1F, 2F, and 3F and 4F. Let's look at the disadvantages. Of course, since it has advantages, but it also has disadvantages, and here we go. High experience needed to perform this process correctly. Yes, if you look at MAG welding, since it is among the advanced welding processes, you must, for you to be good at MAG, you need to have good skills and good experience. So it needs some good training, and so you are such that someone is able to come up with nice work. Then lastly is MAG welding cannot be performed outdoors, as the welding gas needs to be protected from the wind. So basically, if you look at, if you are performing the welding and there is a shielding gas covering the weld area, so if it is performed outdoors, it means that there will be interruption of the shielding gas and the atmospheric gases. Then thank you for watching my videos. Don't forget to subscribe to my YouTube channel, Kalule Edward, the devoted vocational trainer. Bye bye. Let's catch up in the next video.